I'm really sorry. Hello. Hi. Okay, I'm really sorry. I was muted for a while. So good morning, good evening, and good afternoon, everyone. Welcome all. Before we get started, I think a quick reminder to everyone: please mute yourself, and also please switch off your cameras who are on Zoom. And yeah, before I get started, I think I would like to welcome all the advanced and intermediate learners, as well as beginner learners for the 5 week boot camp. This is their first day, I guess. So welcome everyone. And also, to give you a brief intro to about Saran. So he is currently the co-founder of bitsCrunch, and also he's heading the data science team out there. And previously he has done his masters in data science from Ireland. And today he's gonna talk about Pandas, which is one of the important libraries that we would be using in the entire data science journey. And that's pretty much about it. And if you have any questions, feel free to ask on Zoom, as well as if you have any questions on YouTube, please do not hesitate to put down your questions. We have moderators out there who can communicate to us. uh, Sarvanan, it's all yours now. Go ahead.
Yeah,
Yeah, thanks.
thanks, Chanakya. Hi, everyone. Welcome to the hands-on session with Pandas. And I would like to thank Chanakya and DPhi community for providing me this opportunity to uh, provide this session with you all. So let's get started. So before we get our heads on, so I would like to introduce myself. This is Saravanan Jaichandran. I'm the co-founder of bitsCrunch, and currently I'm leading a data science team here. bitsCrunch is all about data analytics firm. We build data products, and we help the companies and organizations to take business-oriented, data-driven decisions. So that's all about myself. And to give you a quick overview about the session, what we will be seeing there is we'll start with installing and using the pandas, and we'll go through what are the different types of pandas objects are there, and how to perform data indexing and selections. And the fourth thing is how to handle the missing data and how to uh, fill the data fill the missing and null values. And finally, what are the string operations which can be easily performed using the pandas library. And finally, concat and append operations. So this is just a high level overview of what we're gonna see in our session. So let's get started. Do you know what is pandas, or does anyone know about or heard about the pandas? Hope the advanced learners and intermediate learners might have some idea about pandas, but to the newbies, do you have any idea about what this might be? Pandas is the funky name. It's not about the cola pandas. Uh, let's get directly into that. So pandas is nothing but the Python package. So it's built on top of the NumPy library, which you have seen in the previous session. And it makes it helps the data scientist to work with the structured and time series data. So it has some predefined three data structures within it, so which helps it more facilitated in working with structured and time series data. So why pandas? What's the key reason we choose pandas for? So there are two key advantages over NumPy. So what is that? The first thing is flexibility. For example, in the previous NumPy session, you might have studied about one-dimensional arrays and two-dimensional arrays, right? And ND arrays. So there we can't able to attach the labels to the particular arrays. But in pandas, we can able to easily attach labels to the particular row and columns. So that's the key advantage over NumPy. And the second thing is element-wise broadcasting. For example, we can easily aggregate or group the data values based on a particular set of values or predefined set of columns. Based on a particular column, we can easily able to group and aggregate the entire data. So that's the second advantage of the pandas library. So without wasting much time, we can directly get into our hands-on session. Hope you will be having the you might have opened your Jupyter Notebook as well, or Google Collaboratory as well, I guess. So if not, so I'll give some few more minutes to open up the Google Collaboratory Notebook. So Chanakya, are you there? So should I continue or wait for some more minutes before I get into it?
Yes, I think just give me 1 second. I'll yeah, people are asking to wait. Let me do one thing. I'll also quickly share the URL with them just in case if someone has missed out. Okay, let me just
Okay.
yeah. Yeah, I think people have opened it, but just in case, let me also quickly share it with them, the URL, both on also one quick thing. If you are not able to, this is for all the learners, if you are unable to run some code, don't get panicked. I mean, like, you can also sort it out later too. I would strongly recommend you to follow the session. So I'm also sharing on YouTube as at the same time on Zoom. I have shared the notebook link. You can open it and save it on your own drive to be able to open and run this particular thing. Okay, you can make a copy of it. Okay, Saran, I think you can go ahead and
Yeah.
start off. Yeah, thanks.
Perfect. So in the previous NumPy session, you might have understood what is exactly an array is and what are the different types of arrays we can create using the NumPys, right? So what we gonna do in this session is we're gonna build on this knowledge and to look after different types of data structures that are provided by the Pandas library. So uh, since this is since we are using a Google Collaboratory, so we don't need to install any of the the packages which are required for data science and doing ML stuffs, so which are already predefined or installed in the Google Collaboratory. So all we need to do is just we can import all these stuffs. So to import the Pandas library and to check for its version, so we can import the Pandas by importing the Pandas library, and we are printing the Pandas version. So also a quick shortcut for the fellow learners. So you don't always have to click run here. So there is a keyboard shortcut here, shift and enter. So whenever you press shift enter, the cell automatically runs. So just give me a minute. The notebook is right now connecting. Perfect. So as you can see, I have imported the Pandas and have printed the Pandas version, and it states 1.0.3. So that's how you install and import Pandas. In order to install Pandas in your local system, so you can simply do install it by using a pip install Pandas, or if you are using a Anaconda environment, you can simply install it by calling conda install Pandas. So that's the
Saran,
first.
one
Okay.
thing, I think, like, we need to change the contrast of your background. Can you make it white? You know how this thing, the
Just give me a
background.
minute.
Yeah, theme somewhere you have to tools command line. Yeah, thanks. Yeah, perfect. And also, like, probably if you can zoom in a bit, that would be great. Yeah,
Okay.
I think people are following it. Yeah.
Cool. So that's how we install and use the Pandas. And in order to use the Pandas library for, to carry out the entire data science tasks, so we don't need to necessarily type in the Pandas whenever we call the Pandas libraries or functions or methods associated with the Pandas library. So what we can do is we can simply call using alias name called PD. So, so that whenever we refer to the Pandas objects or Pandas data, functions or methods associated with the Pandas library, so we can simply call it by using PD dot the respective methods or function calls associated with it. So that's all about installing and using Pandas. And next, the second thing is Pandas objects. So at the very basic level, you can find there are three different types of Pandas objects. So the first thing is series, and the second thing is data frame, and the third thing is integer. So these are the three different types of Pandas objects. And uh, let's see what is Pandas series object is all about. So in this cell, I'm just importing. I mean, you might be aware about this particular import statement, right, in the previous session. So I'm just importing the Pandas and NumPy libraries using their respective alias names. So series object. So Pandas series is nothing but a single dimensional NumPy array. So whatever the stuffs you've seen in the ND array in the NumPy session, you can think of the series Pandas series object as a one dimensional array. So the one dimensional series, I mean, object can be easily created using a list of values or a set of array values. So for example, in this code snippet, what we are doing is we are just creating a Pandas series object and passing in the series of values, list of array values, 0.25, 0.5, 0.75, and 1. So we are just creating a Pandas series object and passing in the list of array values. So, and we are assigning it to the variable called data. So when we call the data, you can see data is of D type float 64. Since we are using decimal values, so the data type of the particular series object is float. So the one thing you need to focus is on here is whenever you create a NumPy one-dimensional array, NumPy array, so you will not find the index values associated with that. So this is the key advantage between the NumPy array and the Pandas series object. Pandas series object wraps both the series objects along with their index values. So this is the key difference between the NumPy one-dimensional array and the Pandas series objects. So you'll get to know as we proceed with the further examples. So similar to the Pandas NumPy array, we can easily able to get the values of the series object by calling data.values. So the data is nothing but the series object which we have created in the previous code snippet, and we are just calling the values of the particular series object. So when we call the particular object, the results will be array of values which we have passed here. So this is one this advantage is similar to that of NumPy array. And the second thing is we can also able to get the index values associated with the series objects. So for example, when we call data.index, so the result would be, so the index range starts at 0 and stops at 4, and the step size is 1. So step size is nothing but the number of intervals between each thing. So this is the 0.25 value starts at, this element starts at 0 and 1, 2 and 3. So this is the index value. And the other thing we can perform with the series object is that we can implicitly call the elements by calling the index of the particular value. For example, if we need to find the 0.5, so we need to call the 0.5 element, second element, we can simply call by data of 1, since this is a basic understanding about an array. So whenever the default array starts with the position 0 and gradually it increase. So if we consider that point, so 0.25 will be the 0th element and 0.5 will be the first element. So when we call data of 1, obviously the value it throws is 0.5, since that is the first element of the data series object. Also, this type of indexing or slicing is called, this type of extracting the values is called slicing. So what we are doing here is we are just calling the values from the element of the first position till the third position. So what here, the first position is 0.5 and second and third. So the one of the key things here you need to understand is, whenever we perform indexing or slicing by specifying the index values explicitly, when we specify the index values, so the stop value, the values which we specify here, which is called the stop value, will not be included, and the value before that particular value only be included and returned. So for example, here first value is 0.5 and the second value is 0.25 and the third value is 1 here. So since here we are calling the index values explicitly using the integer index, so the third value will not be included here. So that's the one key point you need to consider here. And there are two different ways of creating a series Pandas series object. So the first thing is we can create the series object from as a generalized numpy array. So what we do here in the code snippet is same as for the sake of simplicity and for better understanding, I'm just using the same values to create the multiple instances of it. So what we are doing is here we are creating a same Panda series object and passing in the list of data frames. And additionally, what we are doing here is we are just passing in the index values, set of index values. So the indexes are A, B, and C and D. So when you run this, you can find the associated index values along with the key list here. So another major advantage here in the series object is that, so whatever, we can use whatever indexes we like. So it may not, it doesn't need to be sequential, and it can be anything you want. So for example, you can create 1, 2, 3, or 4, or for example, you can create 7, 5, 4, 3. So it entirely up to you. There is no particular set of rules, or there is no sequential or contagious stuffs like that. So when we run the cell, we'll find A, B, C, D, or the indexes of the particular series object. Here, the key thing to note here is when we call the stuffs by using the implicitly using the indexes which we specify here, it will return the particular values associated with the index value. For example, here what we are doing is we are calling in the value of index B. So here index B points to 0.5. So it returns 0.5 as our output. So as I said, we don't need to use sequential or the indexes whatever we use doesn't need to be in a sequential or order. So here we are specifying the index as 2, 3, 2, 5, 3, 7. So when we run this, we can see that the series object wraps the data values along with the index values whichever we pass in. So for example, here whenever we here what we are doing is we need to find the explicit value of the series object whose index is 5. So here value of index 5 is 0.5. So that's the thing the series object returns. So this is one way of creating a series object, and there is another way of creating a series object. We can create the series objects from the specialized dictionary. So dictionary is not a buzzword or for you guys, since you have undergone the basics of Python in the previous sessions. So to give you a quick overview, dictionary is nothing but it's a set of arbitrary values which it's a data structure which has key value pairs, which stores the informations in a key value pairs. So what we are doing here is we are creating a dictionary called population dictionary, and we are passing the key value pairs of 5 different states of America. So here California is the key and its population count is the value, and Texas is the key and population of the Texas is the value. So here we are creating 5 different states of United States, and we are passing in the respective population counts and creating a dictionary here. So all we need to do is, in order to create a series object, we can just simply pass in the dictionary which we have defined here, population dictionary. So when we run this population, we can find that we have created a population dictionary, series object, which wraps the California, the states of USA along with its population count. So and its integer and its data type is integers in 64. So by default, the series will be okay.
Sir, I'm really sorry. One quick question that we have is: are all elements in series should be of same data type like NumPy, or it can be different? This is a question that we have from a beginner. Yeah.
Yeah, it can be different. So it doesn't. It's not necessarily be only be of same data type.
Yeah. And what's the use of this type of indexing? I mean, what's the use of indexing, if I'm not wrong? Shobit, is it correct? Is that your question? Yeah, the question is, what is the use of indexing?
Let's say, so if we have a situation where we have millions and billions of data points here, so we can simply call the index values. So I mean, I guess it's too early to speak about the indexing. So if you are looking for a particular thing or a particular criteria or particular condition in a set of data points which has millions and numbers, so we can easily able to index that the specific set of required set of data points which we require. So
Right.
that's
Right.
the key point on indexing.
Yeah, yeah. You just call that particular index number and get the fetch the value,
Yeah,
right?
exactly.
Yeah. So that's how it helps you with. So yeah, thanks.
So shall I continue?
Yeah. Continue, please. Yeah.
So this is one way of creating the series object using the dictionaries. And for example, same as above, which we have specified, I mean, which we have performed like using data of B or data of phi. So we can also create, I mean, call the series object using a particular index value of California and returns the population count of the particular column. So that's the key thing. And another key difference is that unlike the dictionary, so it also supports array style operations. So hope you remember what we did in the session, right? So array style indexing. So it also, the series object also supports these type of indexing, but you can't find this type of indexing and in the default traditional dictionary, Python dictionary. So that is one more advantage to the series object. So for example, we are specifying we require all the values from starting from California to Illinois, and we print this is the output for a particular thing. So this is all about the Pandas series object, that is, which is first type of it. And what we gonna look next is data frame, so which is the second type of Pandas object. So which is nothing but in order to give you a simple overview or simple at the very basic level, or to make you much more clear and concrete, you can think of a data frame as two-dimensional arrays. So series is one-dimensional array, and data frame, you can think of data frame as a two-dimensional array. So wherein we will be having rows and columns. So we can have flexible number of rows and columns associated with that. So this is the key stuff associated with that. So let's create a data frame object. So what we are doing in the code snippet here is we are creating an area dictionary, same as above, where we have created population dictionary. Here what we are doing is, so we are specifying the same we are doing the creating a dictionary for the same number of same 5 different states of USA along with their square kilometers in area. So here we are creating a area dictionary, and we are creating a pandas series out of the area dictionary, and we are printing it out. For the sake of simplicity, in order to create a data frame, so all we need to do is we need to call in the alias of the pandas library PD and the data frame object which we're gonna create. So what we are doing here is we are calling the data frame object, and we are passing the dictionary of values here. So population is nothing but the key, and the value of the population is nothing but the series object which we have created here in the previous step, and area is the key, I mean the column name, and the value for the area is the series object which you have created in the above code snippet. So and when we print, and we are assigning it to the variable called states. So when we print the states, so here you can find there are two different columns along with their respective population count and area count. So this is how you create a pandas data frame as well. And similar to that, I mean series object, we can also able to call states.index value to find the index of the particular things. And if we need to find the number of columns, we can simply call the data frame object dot columns to bring the respective names of the columns. So this is how we create a data frame, and you can think of data frame as two-dimensional array, two-dimensional array, where we can assign the index values and labels attached to the particular rows and columns. So that's all about Pandas data frame. And finally, the third thing, index object. So here comes the interesting part here. Index object is nothing but a simple data, a simple array which is immutable. So in the previous numpy session, you might have created an array and you might have replaced some values in the present in the array, and you can modify or add to the existing values in the particular array. But you can't do that thing in the index object. So basically the index object is immutable. That means you cannot able to modify nor replace the values in the but once you create an index object. So we can see that in live in few seconds. So what we are doing here is same as above. We are calling in the pandas alias function, and we are creating an index object here, and we are passing the set of array values here 2, 3, 5, 7, 11, and we are printing it out. Same as the Python square bracket notation style, we can explicitly call the array values. So array of 1, since the default array starts with 0, and we are calling here the first element, which is 3 here, and you can find the result of it. And I guess this is a type of thing which you might have not noticed, this type of indexing or slicing. So what we are doing here is, so we are printing every second element in a particular array. For example, this array starts with 0, 1, 2, 3, and 4. So there are totally 4 elements in this, in the particular index object. So what we are doing here is, we are just telling to print every second successive element. So for example, it starts with 0. So the null semicolon specifies that it needs to start with 0, and again the second semicolon specifies that it needs to continue till the end, and the step size here. So I guess you might have seen the previous example which I have shown here. Just give me a minute. So yeah, this is the typical style. Starts 0 and starts with 0 and stops with 4 and step sizes. So here what we are doing is, instead of step 1, we are telling that step size is equal to 2. So what it will do here is, it will take every alternative of the second position. For example, it starts with 0, 2, and it leaves the first element, and it then picks up the second element 5, and it leaves the third element 7, and it finally picks the fourth element 11. So this is the result which it produces. So 2, 5, and 7, 11. Sorry. So this is type of again this is type of indexing or slicing. And we can also able to get an idea about the size of a particular index object, and shape of the particular index object, and n dimensions of it, and d type of it, data type of it. So when we print it, so the index object contains totally 5. So these are the number of elements. So 5 elements over 5, and its shape is 1. So since we are passing in single one dimensional array, this is 5 comma 1, which is 1, and its dimensions is 1, and its data type is integer. So since we are we are not using decimal values, it's integer. So as I said, it's the index objects are immutable. Here you can see that what here I'm doing is, I'm trying to replace the first element of the index object and assign it to the value of 0. So here, what is the first element here? This is the 0th element, and 3 is the first element. So what I'm trying to do here is, I'm trying to assign the first value of the first element to 0 instead of 3. So when I run this, it throws the error. So the type error, as you can see, index does not support mutable operations. So which clearly explains that index objects are immutable. That is, they cannot be modified via the normal means. So these are the 3 different types of pandas data objects which you find, and how you can create it. So next comes the interesting part here, data selection and data indexing. So for the sake of simplicity, I'm using the same example which I have used in the previous section. So here what we are doing is creating a series object, and associating and wrapping it with the index values which we pass here, A, B, C, and D. And what we are doing here is, we are just appending a new value called E and assigning it to the value 1.25. So when you print this, as you can see in the previous step, the series object contains only the value still up to D, and when we append a new value to the series object, it gets appended. So 1.25. So here comes the more interesting part here. So what here we are doing here is we are explicitly specifying the index and extracting the values from the series object. So for example, what we are telling here is we need all the values in the particular series object from the index A till index C. So index A starts with 0.25 and index C is 0.75 here. So we need all the values between the index A and C. So when we run this, we are getting all the values between A and C here. So this type of slicing is called explicit slicing using the index values. So what here we are doing is implicit integer index. So we are not explicitly specifying the index, I mean the value of index which we are using. So here what we are telling is we are telling our model to extract the particular thing, I mean implicitly extract the contents from the array using the integer index. So here we are not using integers as index, here we are using characters as the index. So this is typical traditional style indexing, Python indexing or square bracket indexing. So what we are doing here is we are telling to extract the values of the arrays starting from the position 0 till 0.2. As I have mentioned in the previous section that whenever we use implicit integer style indexing, the values associated with the second column, I mean second, the whatever the values which we specify as a stop value here will not be included. So what we are doing here is we need to extract all the values from 0 till 2, but the value of the second element will not be included here. So this is the 0th element and this is the first element and this is the second element. Since here we are using the implicit integer index, so the 0.7 will not be included here and the only the first two values will be included here. So 0.25 and 5 will be the answers for the particular thing. And finally, this type of indexing is called fancy indexing. So fancy indexing is nothing but you are just telling to extract the values of a particular index values. For example, we need a array value of a particular index A and particular index C. So when we run this, A and E values only pops up here, 0.25 and 1.25. So A value corresponds to 0.25 and and E value corresponds to 1.25 here. So that's all about indexing and selection. And there are two key things you need to understand here. I think this will be some bit tricky, so hope you guys need to have some more concentration here. So there are two different types of indexes, LOC and ILOC. So in order to demonstrate the differences between LOC and IOC, so I'm just creating the Pandas series object same as above. But what here I'm doing is I'm just creating the characters as the list of values here and specifying integer values as index values here. So I'm just printing out the series object. As you can see, these are the respective array values and the index values associated with that, which we pass here. So the first thing, LOC. LOC is nothing but explicit index, right? Whatever I said in the above expression, I mean above section. So whenever here what we are telling is we need explicitly the value of location, I mean the value of index 1 here. So what is the value of index 1 here, which is A. So this prints the value of A. So we are explicitly telling to, I mean extracting the values from the array using the specified index values. So 1. And when we specify the values between, I mean this type of indexing slicing called, so first element, it starts with the first element and ends with the third element. So what here we are doing here is, since we are calling the explicit index, calling the value array values using the explicit index, it only pops only the two values of the index, particular index values 1 and 3, which is A and B here. Guys, I hope this will be a bit tricky, but once I explain you about the ilog, you'll get to know what is implicit and explicit. So just keep in mind that explicit index is nothing but you are just calling and extracting the values based on the whatever the index values you are passing in. So you can explicitly call the array values by specifying the index values whichever you pass in. So that type of indexing is called LOC. And when we use traditional Python style square bracket notation indexing, it's called implicit indexing. So in the implicit indexing, the default array starts with 0 and will be pulling out the values from the array using the particular square bracket notation. So what here we are doing is data.ilog of first position. So obviously first position is B here, right? But if you use the explicit, if you use the explicit index, one value corresponds to A here. So, but we are not using LOC, and we are using ilog. So when we print out the first element, which is B here, I hope this might have given you a good understanding about LOC and ilog. And when we do the same slicing stuff here, we are specifying that our indexing should start from the first position till the third position. So here the first position is B and till C. So total number of thing is C here, right? So leaving behind the A, it just prints out the two values of this as B and C here. So this is all about indexing and data selection. So how can we perform data selection in data frames? So data frames is nothing but there are two-dimensional NumPy arrays which have rows and columns associated with the particular set of labels or indexes. So again, what we are doing here is we are just creating a population and area dictionary stuff which we have done in the previous thing, and the data contains the data frame which has area and population here with the respective population counts and area square kilometers. So we can for example, we can able to populate a particular column here, data select. So for example, if we need to populate,
yeah, good. Sorry, one quick question, but you can complete this. I'll ask after.
okay. So for example, if we need to select a particular column in a data frame or a particular column in a data, so that's where Pandas data frame comes in handy. So for example, if we need to call in a particular column, area column alone, so we can simply call the area column by data of area, specifying the column names here. So when you run this, it just pops up the area column alone. So equivalently, we can also specify instead of this traditional square bracket notation, we can simply call in the traditional NumPy style attribute style access as well. So for example, we can call simply this is a one type alternative for another type of calling the area column. So what we are doing here is again samely we are just calling in the area column here.
Yeah. Saran, one quick thing. I think people are still having queries with ilog and this thing, the previous concept. If you can probably can you repeat it once again if it is possible? Yeah.
Sure.
Yeah.
LOC and ILOC, right?
Yeah, LOC and ILOC. And also one quick question. So basically, is there any difference between LOC and normal array indexing? That is one more question, but probably once you repeat, maybe we can address this. Yeah.
Yeah, sure. So I guess there is a key difference between LOC and traditional style array style indexing, since we are not specifying in LOC, we are just specifying the index values, whatever we are passing in, right? So again, let me explain you a bit. So what here we are doing here is we are creating a series object and we are passing in the non-sequential integer values as index values. So LOC is nothing but calling in the array values by specifying or calling using the index values, whichever we call, whichever we feed in while creating the series object. For example, here index of 1 refers to A, and index of 3 refers to B, and index of 5 refers to C. So for example, what here we are doing here is we are specifying that we need the first, the value of the array which has the index value 1 here. So when we pass the index value 1, which is equivalent to A here, A corresponds to the index value of 1 here. So that's the key difference between the traditional Python style indexing and LOC. So we can index or call the values from the array by specifying the particular index values, whatever the values we pass in.
So basically, like, you mean to say that the index can be anything, right? Like 100, 300. I mean, you can call any, you can give any index number to
Yeah,
these
exactly.
particular
Exactly. So for
series.
example, for example, if I change the numbers to 15, I can create a series object with the index 15 also. So when I run this, you can find that 15 is associated, index 15 is associated with the array value A, right? So when I try to call in ilog using the particular 15th index, I mean the index value which I have created. So when I try to run this, it shows A.
Yeah.
Okay.
Yeah.
So that's what LOC does. And when you call the I mean indexing using perform indexing using ilog, what it does is the default array starts with 0, right? 0th element. I mean the array default array starts with 0th position for 1, 2, and 3. So here the first position is obviously
0.
B here.
Yeah.
Yeah, the first position is 0 is A here, and B is 1 here. So when I try to change this to 0, you can see the output will be A. Okay.
Right.
So that's the key difference. I mean, Python style indexing and ilog are more similar to both are similar, and LOC is different than the implicit or Python style indexing. So that's the key difference between LOC and ilog.
Yeah, I think this makes it clear. So it is very clear, I guess, with this example. So yeah, I think we can go ahead. Also, one quick question: can't we use LOC with implicit index?
LOC with
Implicit index.
no, since we are passing in the our own predefined set of indexes, right? So
Right.
then there will not be then there won't be need of using LOC. So we can just use for Python style indexing, right?
Yeah.
So if you are not using custom index values, then there is no need of using LOC.
Right. Got it. Yeah. Yeah. Go ahead. Yeah. Thanks.
So data selection. Again, we are creating a data frame with area and population, and we are calling in the particular columns of the data frame using either this style or traditional NumPy access style. And what we are doing here is data frame allows us to perform computations much more faster. So what we are doing here is, so we are creating a new column called a density in the data frame. I mean data frame object. And what we are doing, what we are doing in the particular density column is we are just dividing the population column by area column and printing it out the entire data frame. So I guess the area, spelling might be wrong, I guess. Yeah, that makes sense. So what we have did is here we have created a column called density, and we have divided the population column by area column. So this type of, for example, we can able to we can explicitly just a minute. We can explicitly call in a density column if we need. So we can select a particular column as I have explained in the previous area and population example as well. So where if we need to use, in some rare scenarios or in some real world scenarios, there will be a necessity to use the raw values instead of the values which we are seeing here. So for example, in order to access the raw values in a particular data frame, we can call in the function called values to get the raw values. So which is here 4,23,967 can be represented in a raw format, in an exponential format by this way. So this provides a alternative method of representing the data, values in the data frame. So this is one of the key advantage in the data frame. And what we are doing in, ilog, same here we are using the ilog here. So here what we are doing is this specifies the number of rows and this specifies the number of columns here. So what we are telling is we need all the columns, rows till 3, and we need all the columns till 2. So totally in the in the data frame which we have created here, we have totally 3 columns and 5 rows here, right? So what we are telling here is we need starting from starting till the third row, and we need the first 2 rows starting from the first 2 rows. So density column will be omitted, and the first 3 rows, California, Texas, New York, will be returned here. So this is how you perform indexing and selection in data frame. And LOC, we are specifying a predefined set of values. Illinois, so you need all the values till Illinois, and you need all the columns before the till population column. So the results, as you see, contains all the rows till Illinois and the column which above the column before the population is area till population here. So this is how you do selection here. And for example, I guess I have mentioned in the key advantage of Pandas, right? Why we are choosing Pandas. So as I said, element based broadcasting, right? So we can group in a set of data based on a particular columns, right? So that's what we are doing here. So what we are doing here is we are printing out the data points whose density value is greater than 100 here. So as you see, greater than 100, there are only two rows here, New York and Florida, which has density value greater than 100. And so when you print it out, so same New York and Florida, which has greater than 100. So this is the key advantage of the Pandas library, which makes it much more work with the structured and time series data, and it's much more useful than NumPy as well. So these are the steps, and this is how you perform data indexing and selections of all these steps within the Pandas library. And next comes the most interesting part here, handling the missing data. So to be honest with you, you can't able to find the data to be completely structured in a structured format whenever we deal with real world applications. So the real world applications contains number of missing points and null values here. So all we need to do is based on the situation, we need to find some suitable measures to handle those missing values. So let's see what are those missing values here. So there are nan and none values in Pandas. So more or less both are same here. So we can interchange nan and null values wherever we can, wherever they are appropriate. So what we are doing here is, let me zoom in a bit. So we are just creating importing a NumPy and creating a Pandas series object with specifying null value. Second value is none, nan value here. Fourth value is none here. So since we are using nan, the data type of the particular series object is float. So what are the different types of operations that the null values we can do on the null values? So for example, if we have a set of data data frame wherein a particular column has null values, so we can check by all these useful functions. So we can check whether a data frame contains null value. So let me explain it. So what we are doing here is we are creating a same series object and assigning it to the data with the two null values here. And when we run this is null operation on the particular series object, it gives the Boolean results false. So since the first element is 0, 1 here, the result is false, which is not null. And second, we are specifying np.nan, which is a null value, and the Boolean result is true. And third thing is hello here, so which is not null. Since this is not a integer or float value, here we are using the string, right? So it's false. It's not null here, so this is false again. and finally the none value here, and the result of the boolean value is true here. So this is the function of the is null value. So I guess in the starting somebody guessed that whether we need to create similar type of data within a series object, I guess, right? Similar to the numpy, do we need to create the series object which contains similar set of data points? So that's the answer for here. So there is necessity to create a series object with the same data type. We can also create using strings and combination of strings, characters, and null values as well. So this is the first thing. And null, the second function is not null. So opposite of is null. So it's nothing but whether the value is null or not. It throws whether the value is null or not. Let me run it, and it only pops the values which are not null. For example, in the particular series object, 1 and hello or not, is not the null value. So it just pops out the results of the array series object which are not null, and dropping the null values here. So sometimes in some real world scenarios, we might be required to drop the null values, but in most of the cases, we'll not be dropping all the null values, since we might lose some important information when we drop the null values as such. So again, it depends on the particular situation and the type of data we are handling, and what are the steps associated with the data we are doing. We need to make some concrete decision. Either we need to drop in the entire null values, or we can find some alternatives to fill the null values here. So what we are doing here is, since the data, series object which we created contains two null values, we are dropping in all the null values. So drop na drops all the null values here, and only gives out the index values associated with the not objects which are not null. And the second thing is that we can also perform this null operations, and dropping and replacing the null values using the data frames as well, which will be a more concrete example, and which it can be more easy to understand as well. So what we are doing here is we are creating a data frame object with 3 columns and 3 rows. So we are creating a 3x3 matrix here, so which contains two null values. So when you bring the data frame, as you can see, 0, 1, 2 are the null, column values, and we can find there are two null values here. So one key disadvantage here is we cannot able to drop a particular null value or a particular thing whichever is null. So either we need to remove this particular row or this particular column. So instead of doing that, what we can, so we can let us see that using a live example as well. So for example, we have created a data frame which has 3 columns and 3 rows and has two null values, and if we drop any of all the null values, all we'll find is a single row. So as I said, we can't able to delete the particular thing or particular data point which is null. So either we need to delete an entire row or an entire column. So what we did here is it just removed 2 rows, and it just printed out the row which is not which does not contain a null value here. So alternatively, what we can do is we can specify the axis. So default axis here is 0. So axis 0 specifies the rows. So what we did here is we specified to remove all the. Let me give you an example. So if we remove this, let me run it once again, df, and I can explicitly remove the null values, rows which contain null values by specifying axis equal to 0 here, and the result will be same here. And if I need to drop null values, columns, if I need to drop the columns which has null values, all I can do is either specify columns here, or I can simply specify 1. And when I run here, you can see that the third column pops up here only, since it does not contain any null value here. So that's how you handle null values here. And for example, what we are doing here is, here we are adding a third column called 3, column called 3, and we are appending all the null values here. So we have just created a column which has all the 3 values as null. And what we are doing here is, we are specifying that we need to drop all the null values in the columns all. So let me give you a concrete example by running this. So what it does here is, it just completely removed the third column here, right? As you can see that the how parameter tells that whenever the column has all the number of, I mean the complete null values, we can specify by telling that we need to remove all the values of the particular column which has null values. And here comes the interesting part here. So instead of simply removing or dropping the null values, we can fill them with the values either through forward filling. I mean, there are 2 different methods of filling in the handling the missing data, particularly in pandas. So if you take the real world scenarios, there are some machine learning algorithms, smart and near mesh algorithms, which are useful for handling the class imbalance and fill in the missing values. So what we do here is, again, we are creating a series object with the 2 null values, and index list is ABCDE. So as you can see, there are 2 null values here. So what we are doing here is, instead of drop NA, we are using fill NA to fill all the null values with a 0 here. As you can see, the null values are replaced by zeros. So I can able to replace whatever the stuff I need. So for example, I need to replace the null values with the value 7. So when I run the cell, so as you can see, the null values have been replaced with 7. This is one type of filling. This won't be feasible in all the scenarios. So as I said, there are 2 types of handling the missing values. One is forward fill, and another one is backward fill. So forward fill is nothing but, so instead of specifying the predefined set of value, what we are telling is that we are calling in we are passing in the parameter called method, and specifying that we need to fill in the null values using the ffill method. So whenever I run that, as you can see, what are the stuffs, this is the original data, series object, which has 2 null values. And what we are doing here is, we are filling in the values by forward fill. So for example, 1 here, which is the previous to the null value. So we are filling in the values of forward fill of 1 here. So as you can see, this is the result here. So we are replacing the null value with the forward fill using the value which is above it. So 1 here, and the second null value is 2 here, and we are replacing it with the value which is 2 above. So this type of filling in the null values is called forward fill. And also we can back propagate to fill the null values by simply specifying the bfill. So what it does is, it simply replaces the null values from the behind. Instead of coming from top down, it comes it fills the values from bottom up. So as you can see here, null value 3 starts with 3 here, and it replaces the null value with 3 here, and this null value, it starts with 2, and so it fills in the value 2 here. So these are the 2 types of backward fill and forward fill. So this handling the null values have been done in the series object. So let's see how we can repeat the same in data frame. So this is the data frame which we have created in the previous example. So as you can see, there are 4 columns, out of which the third column contains null values completely. So what we are doing is, here is again the same method is ffill, but we are passing in the additional parameter here called axis 1. Since in series object, we just used a single, one dimensional array, but in data frame, we are just having 4 columns, right? So we are asking our data to fill in on the column level. So that we are passing in the access value equal to 1. As you can see, second column for as the value proceeds forward, so the null value for the first the filling in the column starts with the 0th column. As you can see, the first column has the first value none, and it has been replaced with the 1 here, and 4 still remains none after although we performed the fill in NA method using forward fill. The first column has the last row still has the NaN value here. So the reason for that is, since there isn't been a row before that, so that the value stays same as the null value here. So there is no previous column associated to the 0th column, right? So this is the first column, so there is no previous column associated with that. So that's why the null value still persists here. So but as you see here, one is NaN is replaced with 1 here, and third column has been replaced with 2, and 5. This value has been replaced with 5, and this 6 has been replaced with this previous column, second column 6. So,
Saran, I'm sorry, one quick question. So people has this query, what is the difference between null NaN blanks 0 np.nan? So if you can explain this is a pretty common query that we are getting. Maybe if you can throw some light on it, that would be great. Yeah.
Sorry, your voice is a bit breaking. Can you repeat once more?
I'm really sorry. So we have a common query. Is it audible now? Is it better? Hello.
Again, your voice is breaking.
Okay, I'm sorry. Is it better? Okay, let me just put it.
It's clear now. It's clear now.
It's clear, right? So my question is, one thing is, like, what is the difference between null NaN blanks 0 NP NaN? So this is a common question that we are getting. So if you can throw some light on it.
Okay.
Yeah.
So we are creating instead of just specifying the NaN value here, what we are doing here is we are calling in the NaN functionality from the NumPy library here. So we can use based on the scenarios, and both are interchangeable as well. So if you choose more like Pythonic approach, NaN values will suit much more better here.
Okay.
Hello, can you able to hear me?
Yeah, I'm able to hear you. Yeah, go ahead. My voice is low. Hello. Yeah. Yes, sir.
There is a network glitch here.
Yeah, maybe possible. Maybe Gunika, can you help us with this? Maybe if it helps, Gunika.
Yeah, so can you able to hear me now?
Yeah, I'm able to hear you. Yeah.
Yeah, the key difference is nothing but we can't able to perform null value. Mathematical operations in none, whereas we can perform mathematical operations using NaN, since this is imported from the NumPy library, so which is far more used for performing mathematical and matrices operations, right? NumPy libraries more tend towards that. So
yeah,
that's the key thing. We can't able to perform mathematical operations in NaN, and when compared with the NaN, NaN value here.
Yeah.
So we can think of this as an operand.
Yeah, and also probably Gunika has some questions from YouTube. Probably she'll ask.
Okay. Yeah. So we have a common question. If you could explain the drop NA function again.
Drop NA function. Okay.
Yeah, like how to drop the rows, and how to specify if you want to drop rows or columns.
Okay. So we are creating a data frame here. Okay. So which is a data frame which has 3 different, 3 columns and 3 different rows. Okay. So for example, so as you see, this particular data frame has 3 columns and 3 rows and 2 null values here, right? So if I want my data frame or data frame to have all the null values. I mean, to drop all the null values, I can specify it by using the axis column, or I don't even need to specify the axis column, since by default it removes all the null values from the rows. Okay. Either you can explicitly specify by telling that you need to remove all the null values uh, uh, that are in the that are in the rows. So both the way, either you can specify axis equal to 0, or by default without passing any arguments you can call the drop NA function. And if in particular, if you need to drop the null values that are in the columns, all you need to do is just pass in the parameter of 1 instead of 0 here. So 1 specifies the column and 0 specifies the axis here, sorry, rows here. So when I call this, it drops all the columns, since the first two columns has the null value, so it drops and it populates only the third column. So does it make sense?
Yes, yeah. I think, like, 1 second, I think. Yeah, Gunika.
Yeah,
Yeah,
that makes sense.
yeah. Thanks.
Perfect. So can I go ahead?
Yeah, Saran, go ahead. Yeah.
Yes.
So, and we can perform some interesting stuff in the string operations as well. So right now what we have seen is what are the steps how we can handle data, and what are the types of indexing and selection steps, right? So we can do the same steps in the strings as well. So what we are doing here is we are just passing in the array of string values which has some mixed string characters, like some of them are in caps and some of them are in fully caps, some of them are in caps, I mean combination of both capital and small letters as well. So what we are doing here is we are creating a array called data, and we are using a list comprehension to uh, capitalize all the values in the data. So as you see, every first letter in the array which we have created in the data has been replaced with the first letter capital letter. So this is one of the capitalize is one of the string operations which can be done in the Pandas library. And for example, and the second thing is that we have included NA. So I guess somebody have asked the difference between NaN and none, right? So we can't perform any, as I said, we can't perform any mathematical operations, or we can't perform call any options, or I mean functions or methods in the particular none object, but we can do that same thing in that NaN. So here what we are doing is we are including a none value here, and we are performing the same capitalized function here. And when I run that, it shows the error that none type object has no attribute capitalized. So that's the key difference between none and NaN. So, and the second thing is that before that, I would like to enlighten you about all the list of all the string methods. So, which we can't go through that one by one, but you can have a look at that. I mean, look at this available string methods. You can get your hands with this string methods as well. So, the len method populates the length of the strings or length of the characters, whichever you pass in, and the lower string method helps in converting the strings or characters or sentences to the lower case. And these are the stuffs, I mean these are the different types of string methods which we can perform on the Pandas objects. And we are creating in the names using the columns, I mean the data which we have created here. And what we can do is we can call in the capitalized method. I mean in order to, for the sake of simplicity, instead of using that list comprehension, it might be helpful for you to understand a bit more better. So it capitalizes the first letter in here, and these are the available string methods which you can find. And what we are doing here again here is creating a series object which consists of potential names here along with the first name and last name. And we can call in, we can ask our model to translate all the names in the to convert into the lowercase by calling the lower method. So as you can see, all the results have been converted into the lowercase function as well. And if you need to find the number of lines of each name, so for example, what are the number of characters in a particular Graham Chapman, we can call in the function called len, as I said here. So we can able to get the total number of words here. So 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and the space. It accounts, it calculates the space too. So there are totally 14 characters in the first element. And we can also able to check in with the boolean conditions as well. So we can check whether the first name starts with a T. So here the first name starts with, there are two key names whose name starts with a T here. So it should throw true to both these two positions, and rest it should give false, right? So when we run this, as you can see, second position and the fourth position throws true since the name starts with T, and rest false. And if you need to specify, if you need to split the first name and last name using a space character, all we can need to do is just split. We can call in the split function to split the two names. So as you can see, the first name and last name has been splitted using the space and has been replaced with the comma operator. So these are some of the different types of string operations and methods, but there are a lot more to get your hands wet, but you can find yourself and play with it. So, and finally coming back, this is a concatenate and append operation. So there will be scenarios where we need to perform join operations, or where we will be needing, where we'll be required to merge two different types of data frames. So in that sense, we can use the concat and append operations. So what here we are doing here is we are creating two series objects. So these are the values for it: A, B, C, and D, E, F are the array values, and 1, 2, 3, 4, 5, 6 are the index values which we pass in. So what I'm doing here is I'm just concatenating two series objects, series 1 and series 2, and when I print them out, as you can see, the two series has been merged together, right? So one below the other, A, B, C, D, E, F, along with the index values 1, 2, 3, 4, 5, 6. So it doesn't merge based on the index values. Okay, so you need to be clear, since we are specifying explicitly with the index value, so it does not merge based on the index, it just appends one below the other. So this is how you will create, you will perform concatenate operation in series. So don't panic, this is just a display object where you can find adjacent displays of the particular thing. So in order for the sake of in order for you guys to grab this concept much more clear, so I just use this custom function called display, so that I can able to display the respective data frames df1, df2, and both combined together, so one adjacent to the another, so that it makes sense, right? So that's the function for it. And this is the custom function for creating data frame. So instead of just specifying, so even you guys can create a data frame as you progress through this bootcamp session, since it's difficult for us to create data frame by specifying the number of the columns and explicitly telling what are the column names and what are the values it should contain. So I just created a data frame, a custom object for creating the custom method for creating a data frame. So what I'm doing here is I'm calling the make function here, and I'm specifying that here, I'm passing in the two columns, two arguments here. One is for the number of columns it should contain, and the indexes associated with it. So what I'm doing here is I'm just calling the data frame function with A, B, C as column functions, and the values it should contain is 3, 0, 1, 2, and 3. So range of 3. So when I run this, all it shows is A, B, C along with the range of values which I passed together, A0, 0, A1, B1, C1, A2, B2, C2. So you don't need to, uh, uh, this is similar to creating a data frame, and you don't need to worry about much here. So since for the sake of simplicity and ease of explaining the concepts, I have created a custom function. So you can simply think of this as a data frame here. So again, what I'm doing here is, so I'm just creating a two data frames, df1 and df2, and I'm creating the same same column names, one ab, but I'm attaching the values different to it. So 1 and 2, 3 and 4 here, so that you can able to easily understand the concept here. So what I'm doing here is I'm just calling in the p.contact function, so which we did in the series object as well. So we are just passing in the two series objects, series 1 and series 2. Same like that, we are passing in the two data frame objects, df1 and df2. So I'm displaying the, I'm using the custom display function which I have written above. So the df1 function returns the two data frames A and B with the values 1 and 2 associated with that, and df2 with the values 3 and 4 associated with that. And I'm concatenating these values, df1 and df2, but I'm not specifying either the joining or the concatenation should perform horizontally or vertically, right? So by default, it concatenates one below the other. As you can see, a1, b1, this is the data frame 1, and 3 and 4 is the data frame 2. So by default, it appends that one data frame below the other. So if you want to open the data frame towards the in column wise, so we can simply pass in the axis value. So one is the value for axis, right? So we can simply pass in the axis value 1. So when we pass the axis value as 1, we can able to get the data frame concatenated in a column wise. So I guess I have given you the enough steps, I guess. Hope this might be useful for you guys.
One quick question, Saran. You're done, or like you're to discuss some more things?
Yeah, I guess I'm done with all the steps.
Yeah. Okay. Great. So I have a quick question. Okay.
Okay.
And so basically, like people are asking what is the difference between merge, concat, and join. If you can explain, that would be
So since I'm using here concat, right? So I'm just concatenating two. Joining these two data frames or two series objects together. So I'm not specifying a particular thing or particular condition or particular criterion to merge together. So say for example in SQL you might have understood about, you might have overcome, or known about the number of different types of joins, right? Inner join or outer join or left join and right join, something like that. So I'm not specifying here any predefined set of conditions in order to combine together, a two series or two data frames. So that's the key difference between the others.
Thanks. One more quick question: is display okay? So basically, there is one more question which says that if there is a blank in raw data, will that be considered as NaN or none?
Yeah, it will be considered as a null.
As null, right?
Yeah.
Yeah. And is there a function? Is there a function that would allow the space, that would facilitate in such a way that space is not counted?
Yeah, we can pass in some custom arguments, right? So
Yeah.
we can specify, or we can even we can able to replace the two strings if they are separated by space character,
Right.
or if they are
Right.
delimited by the character. So
Right. We just need to call that delimiter. I mean, we need to mention that delimiter there and specify that.
space,
And
exactly.
yeah, great. I hope Mahika, it addressed your question. And quickly going, is display function same as print function?
No, it's not same as print function. So for the sake of you guys to get a clear picture of what exactly I'm doing, since concat function appends without specifying the axis, it appends one below the other, but by specifying the access value, it appends next to the thing, right? So in order for the sake of the simplicity, I'm just using the custom function. So it's not similar to the print function.
Okay, great. And
So it's basically like HTML style representation.
yeah. I hope I'm hoping like it did clarified. Probably Vishnu has asked this question. And also we have another question. Do you recommend using pandas with to speed up pandas? So pandas with modern to speed up pandas.
Pandas with
Modern, I don't know, maybe days, if you can explain it further. Defined function. No.
Yeah, I'm not clear about
No,
what you're.
I think even I'm not very clear about this question, but probably it is a library. So there is a library called as Modern. I don't know if you heard about it.
Mm-hmm.
Wait, let me just quickly search. Even I haven't. Modern library. Yeah, there is a library called as Modern Library, but probably this is maybe these we will come back to you on that bit a little later.
Okay.
And apart from that. Yeah, I think we were able to cover a lot of questions during the session. Guys, if you have any other questions on YouTube or on live chat, you can please feel free to ask. So far, when to use NumPy and when to use Pandas, I think this is a very, this is a very common question. Maybe if you can, I think you have already explained right at the beginning.
Yeah,
Maybe
it
you
depends
can,
on the
yeah.
it depends on the scenario we are working with and the type of data we are working.
Mm-hmm.
So it purely depends on the use case.
Yeah, right.
So, but for structured and time series data, pandas is much more convenient.
Right, true. And also probably we can import data from I think in case of pandas we can read the data from be it SQL database or CSV or
Yeah,
JSON,
exactly. So it has
bunch of
n
other
number of
things.
functions to
Yeah,
to pull
yeah,
in the data into our environment.
right, exactly. And probably we'll educate our learners more on that front in next coming few days.
Yeah,
And
exactly.
and
they,
thanks
might- they might they
thanks
might they might come over this in using a so they might have a clear understanding when they start using with the real world data sets, like
right.
so I guess they have seen the iris data set in the previous numpy session, right?
Yes,
So
yes.
as you progress through the exploratory data analysis section, or dealing with the machine learning algorithms, so
Yeah.
you'll find these pandas and numpy stuffs will be useful, and there you'll get to know about
Yeah,
their
yeah.
importance.
And there is one more question by Vishnu. When you get data, you don't
Mhm.
receive NaN, but you will have none. So what do we do? So none NaN can only be obtained using NumPy when I mean data. I mean
Okay.
raw data. Yeah. So what do you do in that case? I think
So
even this.
basically, you can treat them as, interchangeably, you can treat them as the null values, right? NA
Right.
values. So it
Right.
depends on the column. Either you can decide whether you need the particular things, or the null values are necessary, or if you have n number of data points, and if you drop also, it doesn't make much difference. So you can easily drop them. So, but
Yeah.
you have very few number of data points, or very limited number of data points. But if you drop a set of null values or none values or np dot nan, you might be losing some set of important aspects of the data. So in that case, we need to find some alternatives of either how can we fill in. So in some cases we can fill in backfill or forward fill. In some other cases we can fill in the null values using median, mode, or mean value. So it completely depends on the use case. So it varies based on the
Yeah.
business need.
Yeah. Cool. And I think we have one question from YouTube. So Gunika, maybe you can pitch in.
Yeah. So someone asked, what is
Mhm.
the use case of concatenating data frames? Is it for better visualization?
No, it's not for better visualization. It's for it just for I just used the concatenate function to append the data frames to join or to merge two data frames.
Yeah. Right. So yeah, it is like even in maybe Excel users might know this, where they must have ended up using that concat function to be able to merge two different
Sheets,
cells.
right?
Yeah,
Yeah.
yeah, exactly. So yeah, even in this case, we might end up using it for different purposes. So that's there. And yeah, I think that's pretty much. Let me just quickly check if we have any other questions on. Okay, great. I think we are just getting a lot of thanks now. Uh, yeah, and thanks a lot, Sarvanan, for taking out some time for us, and yeah, thanks a ton for your time. And
Thank you
anything
so
that you
much.
want to add to the community and the absolute beginners and beginners, I mean, probably if you have some small story to share about your own data science journey, that would be great. Something that could motivate
Uh,
us.
what I would recommend is just keep going and don't stop here. And I mean, if you're not unsure about some stuffs or if you're not getting some key points, don't stop here. So just keep moving. In order to succeed, consistency and perseverance plays a major role. So never mind. Uh, as long as you progress, so the speed doesn't mind. So you can always uh, start from the scratch and you can pick up your speed as you progress. So uh, I hope this five week boot camp will help you to achieve all your uh, needs and to become a successful data scientist.
Yeah.
So I'm wishing you all the very best. And once again, thanks for Chanakya for hosting this session and DeFi community. And
Thanks,
thank you so much.
thanks, thanks a lot, sir. And I think I totally agree on your thoughts. As in, I mean, one need to be persistent, and also even if they are failing, I think they should not give up. They
Exactly.
should be persistent and just be there and do it. Just do it. And I think we the community is also supporting, and also we have some brilliant coaches and instructors like you who are helping them throughout the process. And I'm hoping they will go a long way to make things happen. And
Sure, sure.
thanks a lot.
Thank you so
Thanks a
much.
lot to
Thank
all
you
the
so much.
learners, and
Thanks
thanks,
all.
Saran.
Bye bye.
Yeah.
Have a nice day.
Bye. Yeah. Thanks. Bye. Take care.